So this was a Pop Quiz 13, the weekly Pop MCQs Pop Quiz 13. If you have any doubt, question 1. Question 2, any doubt? Question 3, no doubt. Question 4. Okay. In question 4, in the sodium chloride lattice, the number of the chloride ion that surround each sodium ion is called the coordination number. So what are the coordination numbers for the sodium ion and the chloride ion? Look, as we know that the formula for the sodium chloride, the ratio between the sodium ion and the chloride, and what is the ratio between them? The ratio is 1:1 because like sodium is +1, chlorine is -1. So the ratio is 1:1. If we have one sodium ion, it should have one chloride ion. Like the ratio for these ions should be 1:1. So which ratio is 1:1? Is this option A ratio 1:1? No, it's not 1:1. Option B is not ratio 1:1. Option C is 1:1. So that's why we select C as a right answer. If it was the same question, and instead of the sodium chloride, the question was calcium chloride. So calcium chloride is CaCl2. So what will the ratio between calcium and the chloride ion? The ratio is 1:2. Like if we have one calcium ion, there should be two chloride ion. So if there was 6 calcium ion, how many chloride ions should be there? 12 chloride ion. Or if there are, like, say, 4 chloride ion, how many calcium ion should be there? 2 calcium. The ratio, the coordination number should match with the formula, the ratio of the formula, because in calcium chloride, the ratio of the formula is 1:2. So that's why the ratio of the coordination number should also match. But in sodium chloride, the ratio is 1:1. So we should also have a ratio of the ion for sodium, and the chloride ion should also be 1:1. Is it clear? Question 4. So it was actually related to the ratio. Question 5, any doubt? For those who just joined now, this is a weekly Pop Quiz 13. We are discussing the Pop Quiz first, and then we'll start the topic. First, we'll start with alcohols and halogenoalkanes, and the second part will start from topic 1. Question 6, any doubt? Okay, question 6. In question 6, which statement is correct? The relative atomic mass of a chlorine 35 is 35.5. No, this 35.5 is the average mass of the two chlorine isotope. Like we have the two isotopes of the chlorine. One is chlorine 35 and another one is chlorine 37. They have the different percentages. The chlorine 35 is 75%, where chlorine 37 is 25%. The ratio, the average mass of the two isotopes is 35.5. So it should be the average isotopic mass of a chlorine is 35.5, but they say relative atomic mass is 35, which is wrong. The mass of this atom is 35, not 35.5. The 35.5 is actually the average mass of the two isotopes. Relative formula mass of a calcium carbonate is 100.1. So when we work out the average mass, so calcium is there, which is 40.1. Carbon is there, that is 12, and oxygen is there, 16 multiplied by 3. So when we sum this, we got 100.1. And that is a formula mass. For ionic compound, we don't say it's a molecular mass. The right term for ionic compound is a formula mass. Why we don't say a molecular mass? Because in an ionic compound, it's not like only single ions are there. There are many positive and negative ions held together by a strong electrostatic force. So the right term, whenever you use for mass of the ionic compound, we say a formula mass, not the molecular mass. So relative formula mass of a calcium carbonate is 100.1. So yes, it is correct. Why not C? The relative isotopic mass of magnesium 24 atom is 24.3. So you cannot work out from this information, because if it's an isotopic mass, we should know the two isotopes and we should know their percentages. So without just knowing one isotope, you cannot say the average is 24.3. You need another isotope, like example, magnesium 24 is there, and say let's say 25 is there, but we should know the percentages to work out the isotopic mass. What about the relative molecular mass of O2 is 16? That's wrong. It will be 16 times 2, which is 32, because oxygen is O2. So B is the right answer for this. Question 7 and 8 out. 7 and 8. Question 7 or question 8? Question 7, okay. First, whenever you see an equation and whenever you see a reaction, you should always write a balance equation. So in this question, you should assume that the gas form behaves as an ideal. When we say it's an ideal gas, we can apply the ideal gas equation, which is PV equals nRT. So a sample of a magnesium reacted with a hydrochloric acid. As a result, it will produce magnesium chloride, MgCl2 plus hydrogen. When acid react with a metal, it will give salt and hydrogen. These are the products. In the question, 1.7 grams of a magnesium reacted with 50 cm cube of 2.2 mole per dm cube hydrochloric acid at 303 Kelvin at 110,400 Pascal. What is the volume of a gas produced measured under these conditions? Whenever we have the two reactants given, what is the first stage? The first stage is always find the limiting reactant. So first what we have to do, we have to work out the limiting reactant. To know the limiting reactant, we should know the moles, and the balance equation should be there. So this is a balance equation. Now, how many moles of a magnesium are there in 1.7 gram? So it will be 1.7 divided by the relative atomic mass of magnesium 24. So 1.7 divided by 24. What's the answer? 1.7 divided by 24. 0.07. Okay. So this is 0.071. The moles of the hydrochloric acid, we have the volume of a hydrochloric acid and the concentration. To know the moles, we multiply the concentration with the volume. So concentration is 2.2, the volume is 50, but divided by 1000, because it is in cm cube, we convert into dm cube. So we got 0.11. So according to the equation, the ratio is 1:2. Like if we have 1 mole of a magnesium, we should have 2 moles of hydrochloric acid. Or if we have 0.071 moles of magnesium, how many moles of hydrochloric acid we need? We need double of that. So means we need about, because when you add this, you need for a complete reaction 0.071 of magnesium, need twice the moles. So we need 0.142. So what we don't have 0.142, we have 0.11. It means the hydrochloric acid is a limiting reagent. Limiting reagent is the one which used up completely. So whenever in a question, both reactants are given, what will be your first step? You always try to figure out the limiting factor. They don't say this in the question, but you should always work out the limiting factor or limiting reagent. So hydrochloric acid is a limiting reagent in this case. Then whenever we work out the amount of a product, we use the limiting factor. So we use a hydrochloric acid and we need hydrogen, the moles of hydrogen. So how we work out the moles of hydrogen? According to the equation, the ratio is 2:1. The 2 moles will give 1. So if we have 0.11, we have 0.11. How many moles should be there? It should be X. What's the answer for this? So we cross multiply 0.055. So we got 0.055 moles are there. So we got 0.055 moles of hydrogen. Now we need the volume of the gas, and the conditions are not the standard condition, like we don't have 298 Kelvin or 100,000 Pascal. So when the pressure and the temperatures are different, we use the general gas equation, which is PV equals nRT, where P is the pressure, that is 110,400 Pascal. V is the volume, we don't know that. N is the number of the moles, that is 0.055. R is the gas constant, 8.31. And T is the temperature, the absolute, that is in Kelvin, so 303 Kelvin. If we need V, so 0.055 times 8.31 times 303 divided by 110,400. What is the answer? But that answer will be in meter cube, because when we solve, we get the answer in meter cube. What's the answer for this? When we simplify this, 0.055 times 8.31, this is 8.31. So we got 1.25 exponent minus 3. But that is in meter cube. We want to convert into decimeter cube. If we want to convert the meter into decimeter, we are multiplying by 10. But this is a cube, so we multiply by 10 cube, or we can also say 1000. Because if you want to convert the meter into decimeter, you're multiplying by 10. But it's a meter cube to decimeter cube, so you multiply by 10 cube, which is 1000. So you multiply by 1000, what's the answer here? So 1.25 exponent 3 multiplied by 1000. So we got about 1.25 decimeter cube. So 1.25 or approximately 1.3. Is it clear? Discussion? Next we have question 8. Silicon oxide has a melting point of 1713 degrees centigrade. It reacts with a hot sodium hydroxide to form sodium silicate. No reaction occur with sulfuric acid. So if we have oxide, if we have an oxide and we add an alkali, it reacted, but we add an acid, it does not react. So what we conclude for this oxide, because acidic oxide can react with alkali, basic oxide can react with acid, and amphoteric can react with both, and neutral does not react with acid or alkali. So what kind of oxide is this, which is reacting with an alkali but not reacting with an acid? So it is acidic oxide. That's one thing. So we conclude that this is acidic oxide. Then what type of structure this oxide? Because silicon and oxygen, these are the non-metal. Non-metal will have a covalent compound between them. But what about the structure? A covalent structure might be a simple molecular or a giant macromolecular structure. Because the melting point is so high, so what this we can conclude from this, we can say it has a giant structure. So the chemical behavior, it is acidic, where the structure is a giant. So C should be the right answer. Question 9. Element X has second largest atomic radius in its period. Remember, what is the general trend when we move across the period? What will happen to the ionic radius, the size? Ionic radii or atomic radii, as we move across the period, the atomic radius will because when we talk about the metals, because the metal have a tendency to lose electron, where non-metals have a tendency to gain electron. So element X has a second largest atomic radii. So what is the general trend in atomic radius? Across the period, the atomic radius decreases. Why the atomic radius? The general trend. Some exceptions are there, like group 2 to group 3 does not follow the trend. UG and group 4, 5 and 6, like 6 does not follow a trend. So it's usually like group 1, group 2, then group 3 there's a dip because of the change in subshell. Then group 4 is there, group 5 is there, and then group 6 also there's a dip because of like p orbitals appear pairing in the p orbital. Then group 7 and 8 occupy the peak. So this is the actual, but generally when we say, as we move across the, this is about the, no, this is not the graph, this is a graph for ionization energy. Okay, this is a graph for ionization energy. So how we compare the ionization energy with the size? If the ionization is energy, like if ionization energy is higher, then the size will be smaller. So generally, when we move across the period, the size decreases. Why the size decreases? Because the nuclear charge increases. For a same shielding effect, normally it's greater nuclear charge, like this will have 1 proton, 2 protons, 3 proton, and so on. So as the number of proton increase, the size will decrease. This is a graph for, the graph which I plot here is for ionization energy and the atomic number. And here, so if the ionization energy is higher, so atomic radius is smaller. That's I'm relating them together, that when we move across, the size will decrease because ionization energy get higher. So an atom of X has, they mentioned the first, that element X has a second largest atomic radius. So when they give an idea that it is having a second largest atomic radii, so when we compare this, as you can see, which will have, so we have group 1, which is having the lowest ionization energy. If it is having a lowest ionization energy, what about the size? This will have the largest size. So group 1 will have the largest size. Then when we move to group 2 will have ionization energy of a group 2 is higher. So ionization energy of a group 2 is higher than group 1. So what will happen to the size? The size will decrease. So group 2 size will decrease. Then when we move to group 3, the group 3 size will increase. Because if the size increase, the ionization energy will decrease. So what we can say, the largest atomic radius in a general trend, if we, this is a specific trend is there, but if we generally take the trends, so we have the atomic radii and we have the size, it is decreasing. So if we say group 1 is there, group 2 is there, group 3 is there, group 4, group 5, 6, 7, and group 8. So the highest atomic radii, according to this will be the highest atomic radii, this will be the second highest, this will be the third highest, and then it gets smaller. Then atom X has a 3 occupied shells. So it has a 3 occupied shell. So, and the oxide of X is shaken with water. So what this give an idea, when the atomic radius is higher, means this element is in this side. The element X is in this side. Okay. This give an indication that this element is in this side because the higher atomic radius for metals. So, and it is a metal oxide. When they say it's a period 3, because 3 occupied shells are there, so it is a third period. So the period 3 is there, it's a third period element or a metal is there. So when we work out the periodic table, when you see the periodic table, the position of these elements in the periodic table, we have the period 3 elements. So in the period 1, we have hydrogen, helium. In period 2, we'll have lithium, beryllium, boron. And period 3, we have these elements, okay? So what is the journal trend? When we talk about the journal trend, in the size, it's a period 3 element. And generally what will happen, the size decreases. This is a journal trend. They mention that this element is having the second largest ionic radii and it is a period 3. So what is this element? This given indication, this element is magnesium. And when we compare the magnesium dissolve in water or a magnesium oxide dissolve in water. So what kind of solution it will form? It will form an alkaline solution. And what kind of alkaline solution it will form? As we know the solubility of the hydroxide, as we go down the group, the hydroxide become more soluble. Like beryllium hydroxide is there, magnesium hydroxide, calcium hydroxide. So as we go down the group, the solubility of a hydroxide increases. So if the solubility of the hydroxide increases, the pH will also increase. So they will have alkaline solution like, let's say this will have 8, 9, 10, 11, 12, 13. So when we compare them, what could be the pH of a resulting solution? So it cannot be 5 or 7. Why 5 and 7 is not in the range? Why 5 and 7 is not in the range? Because it is, we identify its second largest atomic radii. So it indicate that this should be a metal. Because a metal, the atomic radii of the metal is higher as compared to that of non-metals. So this given indication it's a metal. And it has 3 occupied shells only. So when it is having 3 occupied shell, or it belongs to period 3. So the journal trend, when we conclude, we identify it should be magnesium. And so when magnesium dissolve or period 3 metal dissolve, so what result it will form? It will form a weak alkaline solution. So this is also alkaline, this is also alkaline, but this is a strong alkaline solution. C is a weak alkaline solution. Is it clear? How we conclude the pH of a resulting mixture of this oxide? So first we identify the element, it's a metal. Then from the period, there's a period 3, so we identify it should be magnesium. And because of magnesium oxide, when it is pairing, like it does not dissolve readily, so magnesium hydroxide it will form. As a result, weak alkaline, because hydroxides, as we go down the group, the solubility of hydroxide increases. So top of the group, the hydroxides are less soluble as compared to bottom of the group. Question 10, any doubt? Question 10. In question 10, the diagram shows a melting temperature. Remember the order of a melting temperature. When we have group 1, 2, 3, then we have group 4, group 5, 6, 7, and 8. So what will happen? Group 1, 2, 3, they have a metallic bond. So, and the size of the metal line is smaller and attraction is more. So the melting point increases. Even group 4 also, till group 4 it increases because a group 4 is having a giant covalent structure. That's why the highest melting point. So the peak is always occupied, in the melting point for the peak is always occupied by group 4 element. So the question is, which could be sodium? So first we see the peak, which is having the highest melting point. So this is having the highest melting point, so it must be group 4. If it is group 4, the element, and these are the successive atomic number, so means this should be group 3 element. This should be group 2 element, and this should be group 1 element. Group 1 element is a sodium, so C will be the right answer for this. Is it clear? So the melting point, if it was an ionization energy graph, because the same type ionization energy graph, the ionization energy, the peak is always occupied by the group 8 element in ionization. But in a melting point, the peak is always occupied by group 4 element because of a giant structure. Question 11, any doubt? Working out the average mass, relative isotopic mass or atomic mass of this element. Question 12, any doubt? Question 12. Question 13. Question 14. 13 and 14. Okay. Question 13. Which is a reason why fluorine is having a first ionization energy than oxygen? Fluorine and oxygen are in the same period. Fluorine is 9, oxygen is 8. When we write the configuration of oxygen, oxygen is 1s2, 2s2, 2p, 4 is there. And for fluorine, it is 1s2, 2s2, 2p5. But when we compare the nuclear charge, 8 protons are there, here 9 protons. When we draw the p orbital, like p subshell, this is a p subshell. When we draw the p orbital in oxygen, p4 means like 2p4 means it will be like this. They will occupy singly and there will be a pair in oxygen. But in fluorine, there will be first occupy singly and then they will pair up. This is in fluorine and here this is in oxygen. Now we read the option and check which one is valid option according to the question. Fluorine atom has a fewer unpaired electron. Fluorine atom is having more unpaired, like if we compare fewer unpaired electron, this is an unpaired electron of oxygen, this is an unpaired of electron of fluorine. The statement is correct. Fewer unpaired electron, the statement is correct. But this statement does not explain the concept of ionization energy. Because the ionization energy for a fluorine to be higher, so it should have a stronger nuclear charge. Like the charge in the nucleus should be greater to have a higher ionization energy or less shielding effect. Even though this statement is correct that fluorine has fewer unpaired electron, you can see one unpaired electron, oxygen is having two unpaired electron, but the statement does not support the first ionization energy to be higher. Fluorine atom has a fewer shells of electrons, so this statement is wrong. They have the same shell. This statement itself is wrong. Fluorine atom has more electron. This statement is also true, that fluorine atom is having more electrons. D, the fluorine atom has a more proton. Because the fluorine is having more proton, greater the number of the proton, greater the ionization energy. It will be the when we talk about the shielding effect, fluorine and oxygen will have the same shielding effect. Why? When we talk about the shielding effect, we check only the inner shell electron. So this is the inner shell electron and this is the inner shell electron. So they both have the same shielding effect. When we talk about the shielding effect, we ignore the last subshell and we just take the inner shells, inner subshells. So they both have the same shielding effect. So for a same shielding effect, because the fluorine is having more protons, so stronger attraction, that's why the first ionization of a fluorine will be higher than oxygen. The presence of unpaired electron, if it is having the presence of unpaired electron has relation with ionization, but it should be half filled. Like example, when I say the important thing, the things which will affect the ionization energy, one is a proton number or atomic number, another one is a size, another one is a shielding effect, and the last one is a pairing. If it is having like P3 is there, unpaired electron, half-filled orbital are there, that is more stable, so it will have a higher ionization energy. So it's not like unpaired electron will decide the number, it's the half-filled orbital. If it's a half-filled, it is more stable, so we need more energy to remove electron. So whenever we look for the ionization energy, we check the size, we check if a size is large size, smaller ionization energy. If the size is bigger, you need less amount of energy to remove electron. If a size is smaller, you need more energy to remove electron. And generally what happens when we move across the period, the size decreases. For in the same period, when we talk about fluorine and oxygen, so the size we know it is generally it is decreasing. So fluorine is small in size and it has more proton as compared to oxygen. That's why stronger attraction for a small size. So ionization energy or the first ionization of a fluorine will be higher. Is it clear? The next is question 14. The molecule is a polar. Which molecule is a polar? If we want a polar molecule, we have to check a symmetry. If a molecule is having a symmetry, it will be a non-polar. But if it is not having a symmetry, like I'll give an example. If I draw carbon with 4 chlorine, the molecule is having a symmetry. Like if I divide like this or divide like this, I got a symmetry. It means it will be a non-polar molecule. But if the molecule is not having a symmetry, say three hydrogens were there and one chlorine. So if I divide the molecule, it will not divide evenly. Like the sides will be different. So asymmetrical molecule. So it will be a polar molecule. So it will have a net dipole moment. Now we want to identify which of the molecule is a polar. When we draw the structure, 1,1 dibromopropane. Prop means 3 carbon. 1,1. So first position we have a bromine. The two bromines are attached. This will have hydrogen and this will have hydrogen as well. So this is 1,1 dibromopropane and this will also have hydrogen. So when we compare the symmetry, the carbon symmetry, so here bromine, bromine, hydrogen and this carbon chain. So as a result, what will happen? As you can see here, that this carbon does not have a symmetry. Like one side there's a carbon chain, one side there's a hydrogen, and then two bromine are there. And bromine is more electronegative than carbon, so there will be a partial negative and the partial positive will be there. So this molecule does not have a symmetry, so this is one of the molecule likely to be polar. When we draw the second structure, because I will draw all the structures to explain the idea, we have E12-dibromoethane. So it's dibromoethane. Eth means 2 carbon and E means it's a geometrical isomer. If it was Z, it means they are attached on the same side. But if it is E, so this is Br. One Br is attached up, one Br is attached down. So this is 1,2 E12 dibromoethane. So this molecule is having a symmetry. So when I divide, yes, it does have a symmetry. Like the left hand side carbon is same as the right. The structures are approximately same. Though there's a symmetry in the structure. So when we break the molecule and we find a symmetry in the structure, this molecule is likely to be a non-polar. When we say it's a non-polar, means it is not affected by electric field. So because there's a symmetry, so it's likely to be a non-polar. What about hexafluoroethane? What about the hexafluoroethane? Eth means uh, 2 carbon. Hexa means 6. Fluorine are attached. So 1, 2, 3, 4, 5, 6. So when I break this molecule, I will find a symmetry in the structure. So because there's a symmetry in the structure means likely it will be a non-polar. When we check the last one, tetrachloromethane. Tetrachloromethane means like four chlorine are attached to one carbon. Meth means one carbon. So you can see this molecule is also symmetrical. If I break down, I will get the same structure. So the symmetrical molecules are non-polar molecules, where asymmetrical molecules are polar, which are deflected by the electric field. So A will be the right answer for this. Question 15, any doubt? Question 15, question 16. Question 17. Question 18. Question 19. Question 19. Which molecule can exist as easy isomer? Which molecule is EZ isomer? Question 15. In question 15, which is a skeletal structure of a 3,4-dichloro 2,2-dimethyl pentane? First thing, whenever we want to name them, we have to select the longest carbon chain. And the numbering should start from the nearest functional group or a branch. So when I select the longest carbon chain, say 1, 2, 3, 4, 5, I select it. Or 1, 2, 3, 4, 5. So it's maximum I got 5 here. So 1, 2, 3, 4 and 5 carbon I selected. That's the longest chain. What is not in the chain is a branch. So these are the branches. That is not included. When we count the number, we always start from a nearest branch or a functional group. Here, now if I start from here, if I start from here, 1 and 2, the second position I have branches and I have 2 branches. But if I count from here, 1 and 2, second position I have a branch, but I have only one branch. So if we have the same, like the second position branches are there, then what we give a priority? We give a priority to the number of the branches, the side where we have more number of branches. So if I count from the left hand side, I'll have only one branch of a chlorine. But if I count from the right hand side, I will have 2 branches of methyl. So that's why we counted from the right hand side. So 1, 2, 3, 4, 5. So second position, we have the 2 methyl branches, and third and fourth position, we have a chlorine branches. And when we name the branch, we name them in alphabetical order because chlorine is their C and methyl is their M. So the chlorine is first. So that's why this molecule is 3, 4, third and fourth position. We have 2 chlorine, so we call dichloro. And 2 methyl groups are there, so it will be 2, 2, dimethyl, and 5 carbon in the structure, so we call pentane. So this is 3, 4, dichloro 2, 2, dimethyl pentane. That's why A will be the answer. But what about B? What is the name of the B? So how to work out the name of the B? 1, 2, 3, 4, 5. So these are the branches. So 1, 2, 3, 4, 5. So what is the name of this? This is 2, 4, then 2, 3, like second position, and